we look at this, the crocodilian, they're probably the most closely related animal to the avian species. That's because the crocodilians have 4 chambers in their hearts, just like birds do. The other reptilians only have 3 chambers in their hearts. When we look at the numbers of birds out there are 24 different orders of birds, which is approximately 9,000 species of birds. Okay? Obviously, there is no way we can cover anywhere close to that. So we're just going to give you some generalities. When we look at birds, they have different adaptations. One of the most common is flight. They can fly. That's a lot more than we can do. Some of them are extraordinary swimmers. Okay? If you've ever watched penguins swim in nature, it's phenomenal what they can do. And then some of them are runners. You can't fly with an arm, like ostriches. But man, they can run. Right? If we look at the kind of birds out there, there's some general things. First off, we look at their jaw makeup. Some of the birds are called neognathic, or two-jaw. In these kind of birds, the jaw is very mobile. There's fewer bones in it, and most of the birds fit into this category, like sawzall. He is a neognathic bird. And if you've ever watched his jaws move when he's chewing on something, it's pretty impressive how much it moves around. Then there's the paleognathic birds. This is the old jaw birds. And this includes the classification of ratites. Ratite birds are ostriches, emus, cassowaries, rheas. That's paleognathic birds. And their jaws aren't nearly as moving. They just basically open and close. Right? Some of the modifications to birds are really impressive when you start thinking about the engineering that goes into it. Their bones are very thin cortex bones. But when you look inside of the bones, they're hollow, but they have struts inside of them. Now, if you guys ever played with Legos, or building blocks of any kind, how do you make your thing that you're building really strong? You have to put in braces for support. Well, how do you put braces for support in? How do you know where to put them? Well, we don't. We're not smart enough. But if you're an engineer, you know exactly where to put them. Look at the Golden Gate Bridge. Look at some of the phenomenal structures that are built because they use mathematics and whatever to put these struts in the exact location where the stress is going to be. Well, if you look at the inside of bird bones, and birds don't know how to do this, but those struts are placed exactly where they need to be to make those bones extremely strong, even though they're very thin cortex bones. The hollow portion of the bones is very important in some of the bones. They are called the pneumatic bones. And in some of the cases, the air sacs that are internal inside the coelomic cavity of the bird, those air sacs extend out into the bones, which is kind of an interesting concept if you think about it. Because that air sac goes out into the bone, I could put a hole in the bone, put a catheter in it, and deliver anesthetic gas into the bone, and that would put the animal to sleep because it's connected to the respiratory system. Some of the specific bones that have air sacs in them are the ilium pubis, humerus, sternum, the clavicles, some of the vertebral bones, some skull, and the coracoid bone. Okay? Now, not all birds have that adaptation. And not all birds have air sacs in all of those bones. But those are some of them that might have air sacs inside of them, or air chambers. The skeleton is modified in birds. There's fewer bones, but many of the bones are fused together. For example, the axial skeleton in birds is almost fused from the time it gets to the coelomic area, or what we would consider the thorax, all the way to the tail. It's all basically fused into one big bone. Now the cervical vertebrae are not fused. They're very, very mobile. If we look at the modifications that also are important, in especially flighted birds, they have this thing called a keel. And the keel is a ventral projection off of the sternum. Now, why are there projections or depressions in bones? Okay, something's putting pressure on or pulling on the bone. Well, look at the keel, that big ventral projection. Why do you think it's so big? Lots of pull, lots of muscle pull on that specific spot. Okay? Now, if it's a bird that doesn't fly, that's not nearly as big. A lot of people have considered having an ostrich for Thanksgiving dinner. What a disappointment that would be. They don't have a big breast muscle that everybody likes to eat on Thanksgiving because they don't fly. So there's not much there at all. Okay? The cervical vertebra in birds is a variable number. In mammals, it's pretty easy. There's 7, not in birds. Anywhere from 11 to 25 cervical vertebrae. Okay? And their atlas is completely different than mammals. If you think of the atlas, which bone is the atlas? C1. What's on that atlas that allows it to connect to the skull? 2 condyles, or condylar facets, right? Birds only have 1. Why is that important? Have you ever watched a bird turn its head around? It can go almost 180 degrees. Can you do that? No, because you have 2. And that stops you from being able to move. But they only have 1, so it can really spin around. Okay? The coccygeal vertebra, the ones after the backbone, they're also fused. And the very last one is kind of in a vertical position, and that's called the pygostyle. That makes sense, especially in flighted birds, that they have to move tail feathers to act as a rudder when they're flying around. The skull is different. Obviously, they have a beak or a bill. How it attaches to is very different. If it's a beak or a bill, it's keratinized tissue. Okay? Which means it's very similar to what? Huh? Horns, toenails, claws. Okay? Very, very similar. The attachments are very similar to mammals as well. How it's attached to the rest of the body. Now, birds have really big orbits for their eyes. In fact, in many cases, it's so big, they have to have something extra in there to help support the eyeball, because the eyeball is really big. And that extra support is called the sclerotic ring. And it basically is like a little internal skeleton for an eyeball. Okay? Then, there's ribs that are fused together with the rest of the keel. It goes all the way down. Okay? And they also have this thing called an uncinate process. The thing that extends caudally from each rib. And it comes back and articulates with, if you will, the rib behind it. And what that does is it gives strength to the thoracic wall. Now, penguins don't have rigid ribs. The reason for it is they have to be able to move those ribs around a lot when they're swimming around in the water. The forelimb, or the wing, has a different bone in it that you guys have never heard about before, and that's called the coracoid. The coracoid is a primary bone that attaches from the keel, or the sternum, up to the forelimb. Okay? and that helps to support some special muscles. The bones that are fused inside are the furcula. The furcula is a very special bone that everybody wants at Thanksgiving. It's the wishbone, okay? And it's also really important in supporting the big musculature that's attached to the sternum and the keel. And then the metacarpal bones. All the bones in this area on the wing are fused together, okay? In the bird, the ulna is the largest bone. In mammals, it's the radius, but not in the bird, it's the ulna. They have 2 to 3 digits, okay? Now, the 2 and 3 are the main digits that go out to form the tip of the wing. But then there's this other thing. The remnant of number 1 is called the allula, and that's just this little tiny thing that also has feathers, specific types of feathers attached to it. The rear limb, or the leg, the bones that are fused are the tibia and the tarsal bones, okay? We have the tibia that goes down and it articulates with the talus of the tarsus. That doesn't happen in birds. Their tibia and tarsal bones are all fused together. And then there's a tarsal metatarsus. So if you think about the cat or the dog or whatever, if you take the tibia and the articulation with the tarsus, the talus and the calcaneus, that's fused this way, and then the rest of the tarsal bones and the metatarsals are fused the other way. So now instead of having 7 and then 5 more over here, that's 12, and then 2 up here, that's 14 bones in the mammal. Now you're looking at an animal that's got 2 bones, takes all of that out, okay? Now, birds, when you look at their rear legs and their feet, their toe arrangement is different. Some of the birds are called anisodactyl. Now, an anisodactyl, what does that word mean? An means? Without, iso, same, dactyl. Digits. So anisodactyl means they're not all the same. So anisodactyl means we have 1 toe that goes caudally and 3 that go cranially. Okay? Like a pigeon or a sparrow or a hawk. Okay? Those are anisodactyl types of digits. The other type is called zygodactyl. Zygodactyl is like sawzall. Sawzall has digits 1 and 4 pointing caudally, caudally, and then 2 and 3 point cranially. So this is what a bird has. These 2 go cranial, these 2 go caudal. So if you go back in and look at sawzall's toes, 2 toes grab around the front of the perch and the other 2 grab around the back of the perch. Now, this is really interesting because it shows the lack of education of people that make cartoons. Like Rio. Anybody ever watch that? If you look at the feet of the bird, no, that's not right. It's wrong. Because they've got it looking like they're anisodactyl. They don't have the arrangement the same. And that's what kind of fun things you get to learn, like dinosaurs in Jurassic Park. That was wrong. All screwed up. Right? All right, the pelvic girdle. The bones that are fused in this pelvic girdle area are the sacrum, the coccygeal or caudal vertebra, the ilium, the ischium, and the pubis are all fused together. So it's just basically one bone. So that means the mobility in that area is very different than it is in a mammal. They don't have a pelvic floor. The 2 pubises don't come together on the ventral aspect. Well, that makes sense. It's really distensible. Why does it need to be really distensible? They have to pass an egg out there. And if they had a bone down there, it wouldn't be able to get out. Okay? Now, muscle modifications are quite different, especially in flighted birds. The reason for that is because the center of gravity has to be optimal so that they can get up off the ground. Okay? Now, if you look at the muscle of birds, they have different kinds of skeletal muscle depending on how that muscle is used. They have muscle that is considered white. The white muscle basically is the muscle that has lower blood supply and less myoglobin in the muscle cells. So it appears pale. That kind of muscle is only good for rapid acceleration and it runs out of gas real fast. Okay? So think about that. And this turkey that's sitting there, white muscle is where? Which muscles? You guys eat turkey for Thanksgiving? You eat chicken. Anything that has, if you go to Cane's, Raising Cane's, what color is that meat? White. Why? Because it's breast muscle. Have you ever seen a chicken fly to South America for the winter?
Can't say that.
They can't do it. They can only fly for short bursts, and then they run out of gas. Well, what about a duck? What color is the breast muscle in a duck? Red. It has more blood supply, it has more myoglobin in it, and a lot more mitochondria. So that's why a duck can fly 10,000 miles, because that muscle just lasts for a lot longer. So now you can see, where is the red muscle on a chicken? The legs. Because they can run. Anybody ever watch Rocky? Chasing the chicken around? The chicken ran a lot longer than he did because they have red muscle there. Okay? Now, this concept of flight. Remember, the muscles or the location of them has to be so that the center of gravity will allow flight. So, all of the muscles are ventrally located that have to do with flight. Okay? On the sternum and the keel. Now think about that though. Everybody do this. Okay? Now, go like this. Which muscles allow you to do that? Which muscles allow this action? Huh? What are these muscles? Pectorals. Where are they located? Ventral. How about doing this? Where are those muscles? What muscles allow you to do this? Trapezius, deltoid. Where are they located on mammals? They're dorsally, not in a bird. They're ventral. Okay? And that's what causes them to be able to move their wings in certain directions. Okay? The pectoral muscles are responsible for the downstroke, just like with us. This. That's the downstroke. That's the one that gets really strong lift that allows them to get up in the air. The muscles that cause the upstroke are also ventral in the bird. They all insert on the humerus, but their location of insertion on the humerus is different. The ones that are responsible for the upstroke have to insert on the on the ventral aspect of the humerus, right here. That makes sense, right? But for the other muscles that are on the ventral aspect, they have to insert on the dorsal aspect of the humerus to allow it to pull up here. In order to do that, the tendon of insertion has to go up through a little tunnel and then go around and come in on the dorsal aspect of the humerus. That little tunnel is called the foramen triosteum. Triosteum means what? 3 bones come together and create a little tunnel that tendon goes through, changes direction to insert on the dorsal aspect of the humerus. Okay? The leg muscles are also different location. If you think about it, has anybody ever eaten a chicken leg? Okay? What bone is that that's surrounded by the muscle?
Femur?
The tibiotarsus. That's not the femur. The femur is surrounded by the thigh muscles. The chicken leg is basically from here down. Okay? So, where are those muscles on the drumstick? Are they spread evenly throughout the leg?
No.
Where are they? Approximate. Why? Center of gravity. And they have really long tendons of attachment that go from those muscles that are way high on the bone. And those tendons are really long and they have to go all the way down to the toes. Okay? So they cross over multiple joints to get to where they're supposed to insert. Now, think about that, those tendons that go all the way from the tip of the toe all the way up to the leg muscle. Goes over a lot of joints. If those bones flex like this, what happens to those tendons or to the muscles? They get tight. Okay? That's really important because it's something called the perching reflex. The perching reflex in birds is if the joints are flexed like this, the toes go like this, and they can't come undone until the leg extends. That makes sense, right? Anybody ever watched a bird sleep in a tree? How come they don't fall off? Because their joints are flexed up, and that causes their toes to grab the branch, and they just stay there. They can't let go of the branch until they extend their legs out. If you've ever watched a bird get ready to fly off a branch, they have to extend their legs first, toes let go, then they can fly off. They can't do that if their legs are flexed back. Okay? That's the perching reflex. I saw that really, a good example of that once when I was here years and years ago, right out of vet school. I practiced at Black Mountain Animal Hospital in Henderson. One of my colleagues who you all know and are getting to love is Dr. Cassiopo. Dr. Cassiopo is a falconer, and he flies hawks. Well, we went out with him one day, flying his hawks in a golf course. And at that time, my 2 sons were just little guys. And Chad, my second son, blonde hair, was small enough that when he's trying to walk through the bushes, all you can see is a little blonde head hopping around the tree. Well, Dr. Cassiopo's hawk was sitting in the tree, saw this little blonde head walking through the bushes, bam! Grabbed him right in the head. One of the talons came right close to his eye, one went into his ear, the other side did the same thing. And then, as soon as the bird grabbed his head, he flexed his legs up. I couldn't get the claws out of my son's head. I had to forcibly extend the bird's legs to allow the toes to open up before I could get him out of his head. To this day, he's still afraid of birds. Now, inside the body, there is no diaphragm. That means there is no separation between thorax and abdomen. It's all one body cavity, called the coelomic cavity. Okay? But if there's no diaphragm, how does air get in and out of the lungs? Has to be with movement of the thorax or movement of the coelomic surrounding structures, the sternum and the body, or the backbone. That's the only way that that happens. So if you were to hold a bird and not allow the chest to expand, you will suffocate the bird. You'll kill it. You have to allow that thorax to move, or the sternum and keel to move, I should say. Okay? Now, that brings us to the other type of modification, and that's in the integument. The integument has feathers. Feathers basically have their origin in epidermal cells, very similar to hair. But there's a lot of differences. There's a lot of keratin in those feathers. If you start thinking about and feeling what a feather is like, it's kind of like a toenail, especially when you get way down close to the body where it attaches. The anatomy of a feather has specific names. The first is the callus, or the quill, part that is attached to the body. The next is the rachis. The rachis of the feather is an extension from the calamus and goes all the way up the end. And if you look at a feather, you can see it. That little kind of thin tube that goes all the way up. And then there's the vein. The vein of the feather is the flattened or web-like stuff that extends from the rachis out to the side. The size and the length of the vein is different depending on what kind of feather it is. Okay? If we look at the vein, those things are linked together. Each of those little shafts that comes out off of the rachis, they have little extensions that hook together to the next portion of the vein. Okay? Those little extensions are called barbs and barbules. And when they're all connected together, like this, they're stuck together. Doesn't mean you can't pull them apart, but when you pull them apart and then go back in and touch them together, they're stuck together again, right? Kind of like Velcro. Wonder where they got the idea for Velcro. Now, that arrangement that allows them to stick together makes them very light, but it also creates a wind barrier to allow the wind to have to pass over them instead of through them, even though they have little holes in them. And that's what allows the wings to have their shape, specific types of shape that now gets to physics, how they can get up in the air. How birds fly or get into the air. Somebody's sleeping in our bushes. Oh no, picking up trash again. Okay, anyway. Flight has to do with two basic principles of physics. One of them is called Newtonian physics, and the other one is the Bernoulli principle. Okay? I know I'm going to shake my head at this one, but y'all had that in high school, right? Huh? You know who he is, but you know what his principles or physics are.
I can't remember, but I learned it. Yeah.
Okay. We'll get to that. All right, now, there's different types of feathers, okay? The types of feathers you guys will have to know. And there are examples in the lab over there. The body, or the contour feathers are what make up the basic shape of the bird when you look at them from a distance. So that nice streamline appearance is because of contour feathers. They're also very colorful or not, depending on the kind of bird it is. Okay? They're also very important for protection because of those feathers and how they can hook together. The veins hook together. Tail feathers are called the rectrices. The rectrices are interesting because when we look at the rachis here in the middle, how much vein is on both sides? About the same, right? That's because it's at the tail end, and all of the vein is going to be pointed caudally. But if you look at a flight feather or the Remigi, the leading edge of the vein is very, very small. The trailing edge is really long. Why would that be? When they're flying into the wind, the stress of the wind hitting it causes the vein to be really short. But on the other side, there is no impact with the wind, so it can get really long. Everybody see that? So by just looking at the feather, you can tell, is it a contour feather? Or is it a tail feather? Or is it a flight feather? Just by looking at the shape of the vein. Okay? Now, there are semi-plume feathers. Semi-plume feathers are interesting in that they do not have barbules or hooks on them. Okay? So that means the vein shafts don't hook together. They're just kind of floating around out in the breeze. These are deep to the contour feathers. And if you go and look at Sawzall, you can see these. They're kind of a gray color. They're not real colorful. They're primarily meant for insulation, but they're very flexible. If you look at that feather, it has a rachis that extends all the way from the calamus all the way up to the end. But the vein that comes off, they're not hooked together. Okay? Then we have down feathers. Down feathers have a very, very small rachis. The calamus is there, but the rachis is really short, and then the vein that comes off, again, there is no barbules and no hooks. Okay? These are deep to the contour feathers as well, and their primary function is, again, insulation. Anybody have a down pillow? Kind of soft, okay? Real squishy. How about a down jacket for going up in the mountains? Is it warm? Yeah, because it's insulated with these feathers, okay? Now, another kind of feather is a powder down feather. Powder down is different, and then different birds have different amounts of powder down feathers. These kind of feathers, like you see in this bittern, they're constantly growing. But as they grow, the tips start to disintegrate. And when they disintegrate, it creates a really fine powdery material. And that powdery material is really important in waterproofing. If you've ever had or put your hands on a cockatoo, and when you get your hands off, all of a sudden you can see kind of a really light white material. And if you pour water on it, the water just beads off. Same thing if you touch a duck or a bittern and get your hands covered with the powder down. You have to really wash to get that stuff off your hands because it just makes the water roll off. That's what it does in these kind of birds as well. All right, then there's phyloplume feathers. Phyloplume feathers have a really long rachis, and then they've got barbs coming off the tip of the rachis, but there's no barbules or hooks, so they don't hook together. These are really important in sensation. They stick out way far out into the body, and then the calamus down here has got nerve endings around it. So that when that little rachis up at the top with the barbs starts to wiggle, they can feel it down here. That's really important because it helps the bird know where a specific feather is placed. If you go back to Sawzall and take one of the feathers and put it underneath some of the down feathers, oh, he knows where it's at. He's going to reach around there and he's going to put it back where it belongs. Because he knows, because of the nervous sensation of the feather. Another type of feather is the bristle feather. The bristle feather has a very stiff rachis with just some tiny little barbs right at the base, right next to the calamus. These are usually found around the face and the feet. Okay? And if you go look at Sawzall, you can see them. They're just really tiny little things. These are also really important in sensation, what they're walking around or what they're putting their head into. One of the best kind of birds to see this feather in is a vulture. Okay? They got them around their face, so that when they stick their head in the carcass, they can know what's feeling they're feeling. Okay? But you can see the same kind of feathers on sawzall up around the face. Now, feathers don't grow all over the body. Okay? They grow in something called a feather tract or a terrellate. And depending on which book you read, there's either 7 or more feather tracts. And that's where the feathers come from. But they come out of there and then they cover the entire body. So that means you can start to separate the feathers on a bird, and all of a sudden you're down to the skin and there's no feathers there at all. Okay? And that's typical. The feather-free areas are called the apteria. Okay? So what do you think the Latin word for feather is? P-T-E-R. Okay? Terre. So apteria means no feathers. Terre means that's where the feathers are. Okay? Now, sawzall right now is going through a full body molt. If you look, there are new feathers growing all over the place. Okay? That concept of molting is when they have to get rid of the old and bring in some new stuff. Some birds will molt in a pattern replacement type of a method. That means it's not all at once. But some of them, it's all of them at once. They just start losing a lot of their feathers. The ones that only lose pattern replacement, they can fly really well during their molt. And birds that lose all of them at one time, or losing a great deal of them, they don't fly very much during the molt. Okay? When they are replacing the feather, the new feather that's coming out has a center, or the calamus area, that's full of blood. These are called the blood feathers. What that's doing is it's growing out, it's pushing out the old one, and it just falls off. But it's not growing out fully yet, so it has a long time to go. If you look at that blood feather, there is kind of a hard cuticle that goes around it, and that's called the periderm. If a blood feather gets torn or cut, it doesn't stop bleeding. And in many cases, in order to stop the hemorrhage, you have to pull the feather out and then put pressure on the site where it came out. That means that feather's gone for a long time. Okay? So it's really important when you guys are working with birds, if you see blood feathers, be very careful with them. Don't damage those feathers, because it can be a real problem if they lose it. Okay? Any question about bones, skeleton, muscles? Go ahead.
So spur on a rooster, is that a bone off of, like, or is it?
It's keratin. There might be an extension off of the metatarsal, but it's keratin that comes around it. A lot of people cut it off, especially when they get really long. All right, now let's look at the cardiovascular system. Again, the heart, the starting of it, has 4 chambers, just like mammals and crocodiles. Not alligators, well, kind of, sort of. Turtles, they're all different. Turtles, lizards, they have 3-chambered hearts, and we'll get to that. Okay? The vasculature that comes off of that, if the vasculature goes to flight muscles, or the muscles that are really important, those blood vessels are big, because they have to deliver that blood to the flight muscle. Now, is it white muscle or is it red muscle? It depends on which kind of bird. And the kind of vasculature is going to be different if it's a red muscle flight muscle or a white muscle flight muscle. Okay? Birds also have something called the renal portal system. What's a portal system? guys. What is a portal system? Say what?
Huh? No, I think I'm wrong.
Two capillary beds between systemic arteries and veins.
Okay, for what reason? Huh?
To deliver blood to the tissues.
Well, the regular vessels do that. Is to collect it from a certain area and then deliver it to another area. So the capillaries from one area deliver it down into a small bit of vessel, and then it goes into a big capillary bed again. Well, birds have a renal portal system. That means the blood is coming out of the limbs, the legs, potentially is going to go into the kidneys before it gets to the rest of the circulation. Well, that's weird, especially because there's a valve that controls it. Okay? In some cases, it's going to go, the blood coming out of your leg, it's going to go right to the vena cava and then go right up to the body or to the heart. But in some cases, it's going to change the direction. It's going to go to the kidneys first. Why is that an important thing to understand? What do the kidneys do? You guys know. To filter and eliminate stuff, right? What if I gave an injection of a drug into the rear leg of a bird and the drug went into the kidneys? It would get rid of the drug before it got into the rest of the bird. So that means I can't do that. I've got to give injections so it doesn't potentially go into the kidneys first, because it could remove it. Right? We have to worry about that in dogs? No. If I want to give a shot in the rear leg, give it in the rear leg, it's not going to go into place but to the main circulation. In birds, it may not do that, but it might. But I don't know, because they've got a valve that will change it. Okay? If you look at the blood cells in birds, blood cell erythrocytes, or red blood cells, are all nucleated. Okay? And they are oval shaped, not round. So those are all red blood cells. Well, there's a couple of them that aren't. We'll get to that in a minute. Okay? So, if I was going to look at a microscope and I didn't know what I was looking at, one of the first things I'm going to do is I'm going to look at blood cells. If blood cells are nucleated, I know it's not a mammal. Okay? That means I've got to go a different direction just by looking at blood cells. If we look at the leukocytes, birds do not have neutrophils. Birds have heterophils. The heterophils have granules in them that are kind of rod-shaped. These are the phagocytic cells of birds. So you can see the rod-shaped granules. This is a red blood cell. So there's a heterophyll, and there's a heterophyll in a bird. Okay? They do have eosinophils that have granules. The granules in these are not the rod-shaped big things like you see in a heterophyll. These are really tiny little speck-like granules inside the eosinophil. Okay? They do have basophils, and they have really dark, tiny little granules in them, just like in mammals. What they do in birds is kind of like in mammals. We're not really sure. They may have something to do with the immune system or alterations of responses, but we're really not sure. They do have lymphocytes. The lymphocytes have a big round nucleus, very little cytoplasm. Here's the cell, there's the nucleus, a little tiny border around the outside. That's the cytoplasm. So here's some lymphocytes in birds. Okay? Just like in mammals, the bird lymphocytes are really important in immunity. And they have T cells and B cells. Interestingly, the B stands for bursa. Birds have a bursa. That's where they come from. In mammals, we don't have that. They just come from something else. But we still call them B cells. Right? Monocytes have a large nucleus, no granules, and a lot more cytoplasm than a lymphocyte. Okay? These are also phagocytic cells that help clean things up like the heterophils do in the bird. Now, thrombocytes. Birds do not have platelets. We got it? What's a platelet? A fragment of a cell that doesn't have a nucleus. Well, bird thrombocytes, or the ones that are responsible for primary hemostasis, they have a nucleus. That's why they're called thrombocyte. Whereas in mammals, technically they're not, because they're just parts of the cell. Does that make sense? So that's how you can tell the difference. The thrombocyte in the bird is not nearly as uniform as the red blood cells in the bird. Okay? So, there's a thrombocyte there. There's one there. And that's pretty much all I can see in that slide. There's some lymphocytes in there. There's a heterophil in there. Okay. Anybody have questions to this point? All right. So that's the first lecture for Avian. Now you can go across and start working on the lab portion.